Hey there, and welcome back to the Movement Multiverse podcast. Thanks for tuning in to today's episode, The Martian, Moons, and Moving Like an Astronaut. The Movement Multiverse is a podcast for movement nerds, curious minds, and anyone who wants to think about movement beyond just the gym. Episodes connect how movement shapes our bodies, stories, screens, and everyday life, sometimes getting technical, and sometimes just having fun with it. As a disclaimer, episodes are not intended to treat any individual's medical problems, for education and entertainment purposes only. All right, so welcome back. My name is Max. I am the host of today's episode. Today we were discussing how The Martian portrays movement and how, if it was a real life NASA mission, this crew and Mark Watney probably would have had a different ending than the one that was portrayed in the movie. So, one of the great quotes that Mark Watney shared during this movie was, "Let's science the shit out of this." I'm just going to change that a little bit. Let's science the movement out of this. So, The Martian was a movie made, I think it was in 2015. This was actually my first time seeing it, so about 10 years late, but still a great movie, I thought. I think it's up there with Interstellar, hot take, but I still like Interstellar better, but this is a great movie for those who haven't seen it. Portrayed by Matt Damon is the main character, Mark Watney, who is a NASA astronaut, has to work with his crew to achieve a Mars mission and build up a camp and see I think it was to see if there was, a possibility of life or human sustainment on the planet. So I won't tell you much more, but after that, there's a couple of challenges they face. But I'll just let you know that everyone gets home happy. So let's kind of talk about how they did actually get home. So I'll just give you a little quick background. Mark Watney was on Mars by himself for a certain reason because he was left behind by the crew, and he had to stay there for about a year and a half, which is around, I think they said 549 sols. So Earth's gravity is a little bit more. It's actually a lot more than Mars. Mars is only about 38% of Earth's gravity. So what that means is, since it's less gravity, there's going to be problems with our bodies adapting to less pull on all the tissues. There's also the problem with the soil, so there's little to no water on Mars. There's also only one person there. So it really comes down to how can Mark Watney survive? What was his, pre-planning and training? What was the current, or what was he doing on Mars to survive? And then what sort of strategies could he use to actually get out of the situation if it was real life? So I mentioned that everyone gets home happy. So there really isn't, any big tragedy of this movie, but there is one from a movement perspective. Everyone kind of talks about how the storm, the isolation, the, left for dead on Mars thing happens. But the real tragedy, honestly, is the gym and their space station. So in order to make gravity a thing, we do need to make it something that we train for, so that when the astronauts come back to Earth, as do astronauts in real life from NASA, they train so once they come back from space, they can adapt to Earth's gravitational pull pretty quickly. Because what happens is, if we don't train for that while we're in space, degradation of our tissues, like our bone, our muscles, our some of our organ systems, just they start atrophy. They stop working like they used to. So we really have to train to maintain these things. As a physical therapy student, this is super interesting because a lot of our patients on Earth have similar problems to someone who might have problems in space. It's just the way that it happens is a little bit different in space. So again, going back to that gravitational pull, since there's less gravitational pull, the tissues like the bone, the muscle, the ligaments, the joints start to adapt to that lesser pull, meaning they're less strong, they work less, and they're kind of just lazy. So, in order to combat that, what NASA does right now is they have space stations or ships or whatever they use. They have certain equipment that or astronauts will use throughout their mission to make sure their tissues are adapted to pretty similar to Earth's gravitational pull. So when they land, they can stand up without any problems. They can walk without any problems. It might not be, pretty because there's still like the dizziness that might come with it. So like vestibular problems, maybe some strength loss, but in general, they want to maintain what they have. So when we're talking about The Martian, there's a couple quick scenes where they show the gym in the space station. And if the space station was designed to spin fast enough to mimic Earth's gravity, what they had would be great. They had a treadmill, they had a couple benches with weights, they had, I think, a rowing machine. So, if in real life this actually would not work, so the the size of the ship had to be way bigger at the rate it was spinning to mimic Earth's gravity. So, if we're taking real life physics and putting it into the Martian, since it's a much smaller ship than it needs to be to mimic Earth's gravity, the tissues of this crew would not be prepared to land on Mars and survive Mars for over a year and a half, then go back to Earth and then have no sort of musculoskeletal problems or medical problems, especially with the bone, muscles, ligaments, tendons, all that good stuff. So, what would be the ideal scenario on the Martian ship where Mark Watney would actually have the best chance of maintaining his function, like his bone health, his muscle health, staying strong, and then getting back on the ship, back to Earth, where he can function pretty normally? So, what NASA uses right now are a couple of machines. They have something called an RED, so ARED, where it's kind of a combination of movements that they can do on this thing. They can do squats, deadlifts, all the really important movements that might mimic everyday life. So you might be bending down to pick something up. You might be, pushing something, pulling something. These heavier movements on this machine are able to be done with much heavier weights or go beyond what is actually done on Earth so that the tissues are adapted to more than what is actually needed. They also have a treadmill that will pull them down to the treadmill, so it makes or it kind of sticks them to it harder than if they were just to walk on it. So in The Martian, they had a couple treadmills, but it didn't look like they had any sort of systems that would increase the pulls on the body or the forces that the body would actually withstand. So that's kind of where the problem is. They have a really big gym, but it's actually not conducive to their environment at all. So if we think of athletes, athletes have to strength train, condition for their sport, which means they're putting a lot of time, they are putting a lot of repetition and pretty high intensity to mimic the forces they might experience during their chosen sport. When we think of astronauts, astronauts are actually quite similar to athletes. They have to experience extreme environments and they have to be ready for extreme weather changes. They have to be ready for changes in the pull, like how hard does the planet pull on their body. So a little bit different mindset, but the basics of the training plan are quite similar. So let's first talk about what would happen if they didn't use, which they didn't, if they didn't use the kind of the basic strength training, conditioning techniques that one would use in a real life astronaut situation. Again, like I said, Mark Watney was on Mars for over a year and a half. It takes a long time to get to Mars and back to Earth from Mars. So that's a lot of time in space where gravitational pulls are not present or are much lesser than Earth. So, in my opinion, I think Mark Watney would have had a much harder time than he actually did in the movie. So, if he would have survived that year and a half, it's questionable, especially only living on potatoes. Even though he likes potatoes, potatoes don't have much protein. And when we're dealing with atrophying muscles and bone and other tissues, protein is kind of that key resource for our tissues to maintain their health. So when you combine the less than ideal gym space, you combine the station on Mars didn't have any equipment to actually strength train or anything like that. It doesn't help Mark, especially when protein is not present. So yeah, he was probably, he was the only person left on Mars, but he probably would have been the first person to die as well. So how could he have changed his situation? He had a few good things going for him. He had the space station on the actual planet where he could pressurize it so that there was more oxygen or change the atmosphere inside of the building. He was also able to use his own biological matter to grow his own food. So he had, a decent food source. He had um, the right atmospheric conditions. He had the right gases he could breathe. He had the pressure suit, which is kind of a workout that can definitely um, provide some resistance training. But if he wanted to improve, NASA should have sent him with some real tools to set him up for total success if anyone were to be left behind. So, kind of talking along those lines of some of the things that NASA uses now. So, that RED machine, um, a treadmill with, a cable pulling you down, something to increase the forces more than what he's experiencing just in his daily routines. So even something just super simple where he can do lots of reps really easily throughout his day that doesn't take up time from the sciencey shit is really important to maintaining mood, physical function, mental function, and then being able to actually do the maneuvers that he did to actually get off of Mars. So all this strength and conditioning stuff is super important for astronauts in real life. NASA astronauts go through a long program. They maintain a program once they're on Mars, and then they also have their post program. So they have access to a whole plethora of staff, whether it be surgeons, physicians, physical therapists, exercise physiologists, exercise scientists, and all these people combine equipment, innovation, and basic but idealistic programming to help these astronauts succeed both on their mission and when they come back home on Earth. So, as a physical therapist, we see patients with all kinds of problems. You might hear people going to physical therapists for stuff like joint pain, joint stiffness. They can't move as well as they want to. Balance problems. They can't do the activities they want to as well. Maybe they had an overuse injury, or maybe they haven't moved much at all. And kind of it relates to the problems that an astronaut might experience as well, just due to that gravity component. So we're talking about bone, muscles, and balance problems. Bone is more along that joint pain, joint stiffness, limited range of motion because of the suit or the gravity. You have muscular atrophy, so potentially a quicker rate of loss of muscle. The actual capacity for the muscle to contract is less, which then leads to balance problems because then we're leaning more on our passive structures, so our non-contracting structures like bone and ligaments. Then we have overuse, so as the muscles get smaller, they have to still produce the same amount of force to do the same activities, which means those tissues are being higher stressed and might get overused. And then in terms of our balance and maybe dizziness problems, the vestibular system can affect a whole plethora of things, right? Ligaments, proprioception, so where we are in space, stability, dizziness, it might increase falls, it might increase injury risk. So these are just a few of the problems that astronauts might face as athletes who are experiencing these extreme environments. And yes, I keep saying athletes because astronauts are adapting to these extreme environments just like anyone in a sport or anything else that has to adapt to the demands of their daily life. So we've talked about a lot of the problems that astronauts might face, either in real life or in The Martian, and how Mark Watney probably would have died if NASA didn't give him a real strength and conditioning program like they do in real life, that really long preparatory program, the maintenance program, all that good stuff. So how actually could he avoid this? How much would it cost? What sort of adaptations could he make if he didn't have that strength and conditioning program? So cost, it's estimated that, each astronaut might be spending or, gets allocated hundreds of thousands of dollars for that medical team, the exercise team, the equipment. If we're adding equipment, those exercise machines in space are extremely expensive, millions of dollars. So dividing that across the astronauts that actually use it is probably a much higher cost. So the cost of doing movement appropriately for these missions is high, but it's also a priority because if we don't do it, the result is often not good. So NASA has to consider what's the cost of doing nothing versus something. And in this case, a movement, doing something is of course, the obvious choice. But Mark Watney on Mars didn't have access to any of this. He did have some communication eventually, but it was really for the most important things like just surviving, so food and getting back to Earth. Um, Ideally, if there was a physical therapist on staff from NASA, they'd be also talking to him because although Mark Watney got a little skinny, he was definitely going to be a lot skinnier if he didn't have some of the resources that we've talked about. But let's talk about adaptations. So when you're in this huge suit, the space suit, you're often limited with the amount of range of motion you might have. So you have to change how you walk, you have to change how you do certain tasks, especially when he leaves the space station. So if he didn't have that strength and conditioning program, he might be able to use the suit to adapt to or help his muscles maintain his function. So since it's such a heavy suit, he could utilize it during things maybe like fast walking, plyometrics, things like jumping and all that stuff. So he could use the suit to increase his resistance training. He could do more functional things over, perfect form things. So instead of doing bench press or barbell squat or barbell deadlift, it's more of, can he pick up certain objects? Can he move them around while walking? So just increasing the reps and intensity of doing the things that he already has could have been a viable option. So we've talked a lot about Mars. What about on Earth? How do those basic principles we keep mentioning come back to Earth in terms of maybe if you want to increase your movement frequency or duration, or maybe you're just thinking about fitness? There are a couple really simple principles. Do the thing that you want to be good at. So we adapt to the demands of our environments by doing the things that we need to be good at. So astronauts, they train in lesser gravity environments so they can be mobile and functional in those environments. Athletes lift really heavy stuff, really fast stuff in a fast way so that they can be quick, fast, and take high loads of force in their sport. If you're just maybe thinking about hypertrophy, if you want to grow the muscle, you have to use the muscle. So use it or lose it, a really simple principle that can apply in any environment. We also have the idea of simplicity can go a really long way. We talked about how NASA uses those machines, the RED, for the really important movements like deadlifts, squats, the weighted treadmill, and it's just really only a couple pieces of equipment, but they go such a long way in terms of maintaining our tissue health and getting these astronauts back to Earth safely. And then on Earth, we're talking about simplicity. You don't need to do all the fancy movements you might see on Instagram, that you might see on TikTok. Using simple movements like push-ups or planks, or really, things that are challenging you. If it's challenging you, it's probably enough. You don't have to do any certain thing, any certain way. So using social media as a resource, but not as a crutch or dogma when we're starting to get back into fitness. And then there's that last idea of energy conservation versus energy production. So exercise, strength and conditioning. For some conditions, or maybe some athletes, or really any sort of person who does movement, might try and figure out a way to conserve energy for certain tasks. So, for example, multiple sclerosis, maybe they are planning their exercise very carefully throughout the day so that by the end of the day, they're not super fatigued. But there's also the idea of energy production and how exercise and movement and strength and conditioning can produce more energy for our body so that we can do more things. So how do you balance conserving movement plus producing movement with movement? So those are some basic concepts that I think played well into The Martian, how they moved on Mars and how we can use it back on Earth. I really think that astronauts are some of the most underrated athletes. Using simple and proven concepts often result in good outcomes, really no matter the environment. And then if you haven't heard or read the book Project Hail Mary, I would highly recommend doing it because the new movie is coming out in 2026. And I think it has the potential to take over both Interstellar and The Martian. So that's it for today's episode. If you enjoyed this, please leave a comment on what you thought or maybe some ideas for future episodes. All right, that's it for today's episode. Thank you for tuning in and see you next time.